Welcome back everyone. So here we have some examples on the board and these are carefully selected. We want to solve these special problems because in future you could get some other questions and what you learn from here you can use the same idea to solve problems that look like it. For example, you have in the first one 0.0276 divided by 36.57. And since division implies subtraction, you'd notice you'd eventually have to borrow from a smaller number to remove a bigger number. We'll find out what that means. And I'm comparing these two problems. This one is straightforward, while this one requires a more technical approach. So let's see how we can solve this example. So for the first one, we write our number and the log. So we have here 0.0276 and the logarithm of this. First of all, how many leading zeros are here? There are 2, so that means bar 2. And then we're looking for the logarithm of 2.76. So we look for the log of 2.76 and that gives us 0.4409. Okay, the next one divided by 36.57. So this is a number greater than 1. So we are simply going to punch this in the calculator and it will give us our figure. So we're looking for the logarithm of 36.57. So that gives us 1.563. 1.5631. Okay, so this is division, which implies subtraction. All right, so let's draw our line. 9 minus 1 is 8. 0 minus 3, not possible, so we take 1 from 4, that becomes 10. 10 minus 3 gives us 7. And then we have 2 here, sorry, we have 3, so we take 1 and it becomes 13. 13 minus 6 gives us 7 as well. And then you have 3 here, but 3 can take away 5. So we now have to borrow 1 from minus 2, okay? So if you take 1 from minus 2 and you put it there, you have 13, and 13 minus 5 gives us 8. And you put your point. So now, what does this become since you took 1 from it? So that means you're going to do minus 2 minus 1. So this is the one you took away from it and you have to remove it here, which gives you minus 3. So this becomes minus 3. So minus 3 minus 1. Minus 3 minus 1 gives you minus 4. So you have bar 4 here. That's your minus 4. Okay, so now we have minus 4.8778, and then the next thing is for us to find our antilog, because that's the end of this operation. So what's going to be our antilog? So all we are looking for is 0.8778, and then our bar 4 will determine how many zeros and where the point will be. So we go to the antilog now. So we have 0.8778. So that gives us 7.5474. So we write 7.547. Let's stop there. Deliberately, I didn't put the points because it wouldn't matter since this number is less, much less because of the bar 4. So how many zeros am I going to write? 4. 1, 2, 3, 4. And logically the point will be here. So the answer is 0.0007547. And that's our final answer. So let's take the second example. So in example 2 here, we have our number and we have our log. So what are we looking for? We're looking for the square root of 0.026. So let's write it down. Remember that this could be rewritten as 0.026 raised to power 1 over 2 because it's square root according to the law of indices. So that means I'm going to find the logarithm of this number and I'll divide it by 2. So first, the logarithm of 0.026. So how many zeros are here? We have 2. That means it's going to be bar 2 point. So what is the logarithm of 2.6 log 2.6. So that gives us 0.41. So that's 0.415. That is about 2.415. So let's stop there. Okay, so what's next? This was raised to 1 over 2, which means we're going to divide this by 2. So if you divide this by 2 straightforwardly, you're going to get the accurate answer. Now that's where the comparison comes. So take note. So you could divide this normally, just put in a calculator, minus 2.415, and you're going to get the accurate answer. And that's because the characteristic, the value, the number in the characteristic is the same with the number that is dividing this logarithm. So minus 2.415, so divided by 2, and that gives us bar 1.2075. So the next step is to find the antilog, because we are done with the operation. So let's now find the antilog, and that is 0.2075. So we are looking for the antilog of 0.2075. So that is 1.6125. So this is bar 1, which means 10. So we put it here, and then we put our point, and that is the value. Okay, let's take the third example. So we have our number and our log, and here we have the cube root of 0.057, which could also be rewritten as 0.057 raised to the power 1 over 3. So we're going to divide the logarithm of this number by 3. So let's find the logarithm of 0.057. 2 leading zeros here means bar 2 points. So what is the logarithm of 5.7? 5.7. So that gives us 0.7559. Okay, so we're dividing this by 3. Now, notice that you're dividing this by 3, so you can't just divide it normally. You can't just put it into the calculator and you get the correct answer. It's going to be wrong if you do it that way, because this characteristic here is 2, but it's being divided by 3. So whenever the characteristic and the number, that is the divisor, are not the same, make sure to separate it. So what do we mean? We'll go to our rough work now, and we'll show you what separation is. So this is bar 2.7559 divided by 3. Normally, as we said earlier, this negative here belongs only to the characteristic, and that's why it is put at the top. All right. So if we must separate this, we're going to follow a very tactical approach. So this becomes minus 2 over 3 plus 0.7559 over 3. Now observe that I've not really changed anything, because these are like two fractions. If I sum them up together, I'm still going to get negative 2.7559. But there's a reason why I needed to separate it this way. I'm going to perform an operation here that will make us have negative 3, which makes it easier to divide this and get a whole number instead of getting another decimal here, and also do the same here, but would not change the value of this expression, of this fraction. So now, let's do something. Minus 1 plus 1, what does it give me? 0. Minus 2 plus 2 gives me what? 0. Minus 100 plus 100 gives me 0. So minus any number plus that same number always gives 0. So we are going to apply this principle to this expression that we have. So what will we do to minus 2 that will make it become minus 3? It is if we apply minus 1 to it, right? So let's have minus 1 here, and we also have plus 1 here, so that the effect will still be equals 0. So it's going to change the look, but it's not going to change the value. So minus 2 minus 1 gives us minus 3. So we'll come down here, right? Minus 3 over 3 plus, so plus 1, where it's going to naturally sit here because it's a whole number. So this becomes 1.7559 divided by 3. So now it's easier for us to get a whole number, which is negative 1, when we divide this and simply add it to this and write down our answer. So let's quickly do that. So we're going to divide 1.7559 by 3. So that gives us 0.5853, okay? So now, negative 3 over 3 gives us negative 1 plus 1.7559 over 3 gives us 0.5853. So if you add this together, you'll be having this division to become by 1.05, sorry. So you'll be having by 1.5853. That's the result of this operation. So finally, you find your antilog. So the antilogarithm is going to be, we're looking for 0.5853. 0.5853. So that gives us 3.849 approximately. So, and how many bars are here? So that means 0, just 1. So we put it here and then put our points, and that is our final answer.